This is 6.2 ISN, and we just wrote down the definition of a parallelogram. Properties of the parallelogram are coming up next. Opposite sides are congruent, and that's what these markings indicate. So let's label it ABCD. Okay, and in the diagram, AB, segment AB is congruent to segment DC, and segment AD is congruent to segment BC. When we were doing last semester, we did some proofs, and in there we said that if segments are congruent, then their measures are equal. So you could write from this that AB equals DC and AD equals BC. That means the distance from A to B is equal to the distance from D to C, etc. You don't really have to have that. You just need to know the opposite sides are the same size. I'm going to label the next one ABCD. Just keep doing that. Another property of every parallelogram is that opposite angles are congruent. So in this case, angle A is congruent to angle C, and angle D is congruent to angle B, which means their measures are the same. And of course, you could write the measure of angle A equals the measure of angle C. That's how that's read. Measure of angle D equals the measure of angle B. Another property of a parallelogram is that consecutive angles are supplementary. If I label this ABCD, consecutive means one angle after the next. So it's like one after the other. Boom, A and B. A and B add up to 180. So we are going to just write down that the measure of angle A plus the measure of angle B equals 180 degrees. I could also do the bottom two. The measure of angle D plus the measure of angle C is 180. But we have two more pairs of consecutive angles. What other angles would be also supplementary? You can go across and you can go this way too. So angle A plus angle D. Measure of angle A plus the measure of angle D is also 180. And down and up on the other side, the measure of angle B plus the measure of angle C is also 180. So you can go in any direction. One angle after the next will add up to 180. Okay, the following is another property of parallelograms, the diagonals, which is a segment drawn from one corner to a non-consecutive corner. The diagonals bisect each other, which means they cut each other in half. Okay, so I'm going to label this ABCD, but I'm also going to need a point in the center, and I'm going to call it E. So in our diagram, segment AE is congruent to segment CE. And I'm not going to write that their measures are equal. We understand that we can go forwards and backwards with that. Segment DE is congruent to segment BE. And that's what the slashes are showing. Okay, anybody still need anything on this page? Okay, we have a little more at the bottom of your page to do. Another one says if a parallelogram has one right angle, then it has four right angles. So if this is ABCD, then since angle A is a right angle, angle B is also 90 degrees, angle C is 90 degrees, and angle D is 90 degrees. Okay, and finally, each diagonal of a parallelogram separates the parallelogram into two congruent triangles. The one that they showed here is the longer diagonal from C to B. It's saying that triangle ABC is congruent to triangle DCB. That would be something we learned last semester about how to name a triangle congruence. But we have to include, let's draw one though for the other diagonal. So I'm just going to copy that picture. And they did label it differently than I did. A, B, D, C is how they labeled it. And then I'm going to connect from A to D here. So I drew in the other diagonal. And I could make the statement that triangle CAD would be congruent to triangle. Since I started with C, I'd have to start with B for the other triangle. I went to A, so I'd have to go to D and then A. BDA. Okay, that's enough of that. Then you have one problem there at the bottom that's suggesting we use our properties of parallelograms to solve. To find A, you can see the opposite sides are congruent. So you have to know whether you've got sides to compare or angles. So to find A, we would do 2 times A is 34. We would divide by 2 to find out A is 17. To find B, it says 8B degrees, which means that's an angle. And angle A is congruent to angle C because they're opposite angles. So 8 times B equals 112. To solve it, we would divide by 8 and get 14. Okay, we need to flip the page now. And I'm going to talk to you about using the properties of parallelograms to find missing things. There are some angles we've got to figure out here. The first one, the very most obvious one would be this is congruent to this because of one of the properties we just discussed. And it would be opposite angles are congruent. So that makes Z equal to 105 degrees. I'm going to write down how I'm getting my answers. Not that you always have to, but I think it's very good for your notes. Now I'm going to do something else to figure out the others. I'm going to remind you of something. These two lines are parallel. And remember, this would be called, what's this thing called if you draw a line through two parallel sides? This is called do you remember the word starts with a T? Transversal. Okay. If you have that Z, then you know these angles are congruent because what kind are they? Alternate what? Interior. Okay. So we know that, and I'm going to call this again ABCD. Since AB is parallel to DC, that implies that alternate interior, oops, I didn't write the T, alternate interior angles are congruent. So if that's the case, what can we find by what I highlighted? It would be X is 31. All right, now that doesn't work so well with those two parallel lines for the other one. Then we have to look at this fact. that AD is parallel to BC. So if you use that transversal again, now it's going to be this angle is congruent to this angle. So angle Y, so the reason again, what I'm going to write down is that AD is parallel to BC. Therefore, and those are segments, I guess I should have put segment bars on there. AD being parallel to BC gives me alternate interior angles congruent, again, which tells me that Y is 44 degrees. Okay, so that's all stuff that you can get for that picture and why. What property of the parallelograms will we use to do the next section? Yeah, there are some vertical angles that are congruent in here, but I guess what I need you guys to see, and this is probably one of the trickier things about this, is that these things are the diagonals. Okay, so the property is that the diagonals bisect each other. And since the diagonals bisect each other, y plus 1 equals 26, and going the other way, x minus 2 equals 19. So to finish solving them, subtract 1 and you get y is 25. Add 2 and you get x is 21. I guess I could have put slashes here. Double slash, double slash. The diagonals are not equal to one another. So one of the hardest things to do is to be able to tell if they're talking about angles or sides when you're looking at the diagrams. One property we haven't used yet in our examples are that the consecutive angles are supplementary. So see these two angles? They add up to 180. So 6x plus 7x plus 11 equals 180. 6 and 7, 13x plus 11 equals 180. Subtract 11. What's 180 minus 11? 169. And then you got to divide by 13. Should be 13. And if you wanted, you could plug back in and you could find out the measure of the angles. But all it asked for was the value of x. Okay, there's one more problem we need to go over in the ISN. Does anybody still need this page? Okay, I don't see anybody say. All right. The midpoint of the line segment joining 2 points is the following formula. You add the x's and divide by 2. You add the y's and divide by 2. Well, why would I want to know this? The diagonals, oops, I just started writing that word wrong. Diagonals bisect each other. So if they bisect each other, where are they going to meet? So they meet where? At the midpoint, yep. That's the whole point of this. So what we're going to do is draw where these points are, 1, 1, H, 2, 3, 6, 3, 5, 1. And then I'm going to connect them. And the whole point of this is, if the diagonals, it says find the coordinates of the intersection of the diagonal of HJKL with the following vertices. Diagonals is what it should say. So we're going to try to figure out where these points, these line segments meet. Now, if I were to do an estimate, it looks like it's going to happen at 1, 2, 3.5 or so, 2. See what I'm getting at? I'm looking for where this spot is. And it's the segment JL, and we need JL's midpoint. So let's start with J to L. These are the X's, the 2 and the 5, so I'm going to take 2 plus 5 and divide by 2. I'm going to add the Y's, 3 and 1, and divide that by 2. So what you need to remember is you got to add and then divide by 2. If I got 7 divided by 2, that's 3.5. And I've got 4 divided by 2, which is 2. Now to verify it, say you're wanting to prove that this thing's a parallelogram, you can take the other 2 and see if you get the same midpoint. So if I took and found the midpoint of HK, I would do 1 plus 6 divided by 2, and I would do 1 plus 3 divided by 2, and guess what? You get the same thing. So 3.52 is the midpoint of both of those, and that is where we thought it was going to be, 3.5, 2. The midpoints of the diagonals are equal, are the same. All right, it's a lot of stuff. Okay, next we're going to the packet, and we'll see what we get to there. Oh. I'm going to open a fresh one. Save this as my second hour, or my 4th hour. Shut that up. Okay, 6-2 notes, not ISN. I need 6. I'll delete that section. Okay, 6-2 parallelograms. We're going to go kind of quick because what we're actually doing, these are quadrilaterals, which we're going to study all of them. We're doing this guy right here, first one, parallelogram. Any 4-sided polygon is called a quadrilateral. A segment joining any 2 non-consecutive vertices is called a diagonal. A special kind of quadrilateral in which both pairs of opposite sides are parallel is called a parallelogram. These arrows, if they're not clear, you can darken them, but I think they look pretty good on that page. Okay, that's the definition of a parallelogram, a quad with 2 pair of parallel sides. Don't have time for the website today. So, opposite sides are parallel, what we did on the ISN, and this is going to be a repeat, so I'm going to go rather quickly. A, B, C, D. We just said AB is, segment AB is congruent to segment DC, and segment AD is congruent to segment BC. You do not need to, we're not going to write everything we wrote down in the ISM. With ABCD, diagonals are congruent. We wrote down that angle A was congruent to angle C, and that angle D was congruent to angle B. Opposite angles are congruent. If I label this ABCD, we said consecutive angles are supplementary. So I'm just going to write angle A plus angle B. I'm not even writing the measure because I want to simplify this. Some books don't require that you write measure. Angle A plus angle B is 180. Angle B plus angle C is 180. Angle B plus angle C, the bottom two equal 180. And the left side, angle A plus angle D is 180. Okay, and this is just if you want this in your notes. ABCD again. And then I put an E in the middle because I needed to say that the segment AE equals segment CE, and segment DE equals segment BE. ABCD. Pulling. Good luck. Okay, if you have one right angle, then the rest are also right angles. So angle B is 90, angle D is 90, and angle C is 90. All right, and finally, we talked about that a diagonal bisects the parallelogram into two congruent triangles. This is one set, and we went ahead and drew that there's another set. They had labeled this one ABDC, and we wanted to show that that diagonal also creates triangle CAD congruent to triangle BDA. Okay, and the next thing is to start using these properties in order to solve problems. This problem is the one on the bottom of the page, on your first page. Find A and B in this diagram. Isn't this on the bottom of the first page? Yeah. Okay, opposite sides are congruent. So I can do the top two, one and the bottom one, and the left and the right. 3A minus 4 equals A plus 2. We would subtract A from both sides first. 2 times A minus 4 is 2. Add 4. We got 2 times A is 6. Divide by 2 and we get A is 3. Solve for the other variable, which is B. I think I better start with 2B. 2B or not 2B? All right, B plus equals B plus 1. I heard somebody say that. Oops, I wrote a plus sign instead of equal. Want that? Equals B plus 1. Subtract B and you get a B is 1. Okay, you got to flip the page in your packet. The property we're using here is if you have one right angle, then you have all right angles. Okay. Which means 3 times x is 90. Divide by 3 and get x is 30. Also means 4 times y is 90. And what is 90 divided by 4? Isn't that 22.5? 22.5, right? Okay. This one has all sides congruent. That's what those slashes mean. You guys remember What kind of figure had all four sides congruent that was not a square? Back in probably 6th grade? Okay, yep, I heard it. It's a rhombus. You guys called them diamonds way back in the day? Right. You did call them rhombi? Okay. I've heard a lot of kids say diamonds until they get older and then they finally find out it's a rhombus. Maybe it was before 6th grade that you did diamonds. I don't know. But anyway, sides are all equal. So 6x equals 12 divided by 6, we get x equals 2. These are such short one-step equations that I'm just going for the answer. I'm not showing any steps. What would 3y equal? Yep, 12 also, because all these sides are marked congruent. All right, and that will give you y is 4. There is no number 4. Don't know what happened to it. But I've asked each of my classes, like this is the 3rd time I had to do this today, what are we going to do to find x? There are two ways to think about this problem, okay? I don't know no, it's not equilateral because this is 60 and that's 55. But you're right about something you said. You said something about 180, right? So what were you thinking? Like an equation? 2y plus 60. That wouldn't be quite enough to get the 180. Cadence? 2y plus 60 is not, this won't equal 180. Okay, hold on. Nathan? Plus, okay, I need to add this up too, don't I? If I want, okay, I think we're thinking different things. Consecutive angles are supplementary. If you're using that, then you got to add these and that to get 180. Is anybody thinking alternate interiors? Nathan? Okay, 55 can go down here, right? Alternate interior angles are congruent. 60 can go here. Now what adds up to 180? 2y plus 60. What have I got to add on to this? I got to add the 55 too, equals 180. All right, now, let me show you what I meant by the consecutive interior angles. If you went here to here, doesn't that mean you got to add that all together plus this? That's going to give you the same equation. Okay, so it has to be 2y plus 60 plus 55 equals 180. All right, so I'm going to add 60 and 55, get 115. I'm going to subtract my 115. I'm going to have 2 times y is 65. Yep, divide by 2, you get 32.5. Now, going this way, you could have done these consecutive angles, or you can add up the 3 in the top triangle. So 5x, 55 and 60 is 115. That equals 180. You're going to subtract 115. You're still going to get 65. And then you're going to need to divide by 5, and you're going to get 13. Okay? All right, number 5. What are we going to do to find x? If you have one right angle in a parallelogram, you have 4. Okay, so 6x equals 90. That's the way to start. And that gives you x is 15. So how am I going to do this? Okay, these are sides though. So now this is saying 8y would be equal to 88. Dividing by 8, you're going to get 11. Okay, I want to get a little further. I'm going to go on now. Number 6 and 7. All right, please look. I'd like someone to tell me an equation for me to solve for x. How can I find x? I'm not getting much help right now. What kind of angles are these? Consecutive. All right. Consecutive angles are congruent. All right. So anyway, these add up to 180. So I've got 18x equals 180. I divide by 18 and I get x is 10. Now, what can I do to find out what 3y equals, Cadence? Going like this? Or do you want me to put it up here? Oh, that's okay. So you want me to say those add up to? Is that what you're asking me to do? Then that would equal 180. Okay. Yes, this works. How about another way? They may think of another way because there are more than one way. There is more than one way. What if you put in the 10 here? You'd have 120, and 3y equals 120. Opposite angles are congruent. So you see how this is going to give you the same thing? Okay, 3y equals 120. So y is going to be divide by 3, get 40. Okay, number 7, these are sides. Opposite sides are congruent. So 30 times x equals 150. Divide by 30, and we get x is 5. How can I find y now? Y equals 72x. Uh-oh, I got variables on both sides. Cadence? Okay, put 5 in for x, right? 72 times 5 is 360. 360, that's weird. This is about sides. Do not confuse that with angle measures. If you divide by 2, you're going to get y is 180. And it's nothing to do with straight lines or angle measures. Okay? Nothing to do with that. Just side lengths. Okay, and I'd like to get these two out of the way here. Diagonals bisect each other, so 3x equals 12. That will give you divide by 3, get 4 for x. And then going this way, 4y equals 8. So those are super easy ones. Diagonals bisect each other. Okay, and the last one we'll have time for is the next one. Strategies for this. You guys did not have these diagonals being perpendicular. Put the right angles in there, please. Because you need to have that to help you do the problem. However, I can tell you something. These triangles are isosceles. If that's 60, now this would be 60. These triangles, that triangle adds up to 180. So 2x plus 60 plus 90 equals 180. So actually, you're going to find out that x is equal to 30. And you're going to get x is 15. And the same process for the other one. 4y actually equals 30 because this angle is 30. That angle is 30 also. And so it's y is 7.5. All right, do your best to do some of the problems in the packet. We will continue working tomorrow. We did not get quite as far because of the calculator thing, so I'll record some more tomorrow.